today's is the today's workflow. So I mean, so we can in my mind, so we can firstly design. We can firstly talk about. So let me draw it here. So we can firstly talk about the feature requirements, and then talk about some non-feature requirements, and then so we can dive in some estimations. I think like capacity estimations. And then so we can talk about some high-level designs and maybe we can also if we got a chance, we can talk about some DB, and then so if we have some time left, we can also talk about something that we both interested in, like to as a dive in. So do you think that workflow works for us?
Yeah, so do we need to discuss about the API function?
Yeah, right. So I think I was thinking probably before or after the API, the high-level design, so we can talk about the API. So yeah, definitely. The API is one of the other points.
Okay, sounds good to me.
All right, so if talk about the features, I actually have some questions. So so what is the scale of the system?
I think what about we start from a small scale of the system? Let's say that a system that can crawl like crawl about 100 URLs that at the same time, then we can scale. Then we can design more about the scale to say that how do we scale this.
I see. Okay. Okay, so you mean like the Rapley QPS can be 100 page per second, like this means like the same time, right? And okay. Another thing is oh, I see. Okay, so okay, so if we scale up, so do you have like a roughly estimation for like what is the upper boundaries? I mean, for example, we can crawl like 1 billion page per month. That's actually I think that will be a medium size. Do you think like
that sounds a good upper bound to me.
Okay, so we can say like target can be 1 billion page per month. All right, so and the second question is for the content of the crawling. So what types of the crawling it will be there, like HTML and photos, I mean pictures or some other things. Do you have this?
Yeah, so let's confine the scope to just all the text and the photos. So we will consider only all the HTML and plus photos. That will be the only two parts here.
Okay, so it will be like HTML, which contains PXE and photos. And the third one is because it's a web crawling system. So do you have estimations of how long that all the data will be storage? For example, like maybe we can storage for a year or like 5 years.
Let's assume that this data will be saved for 2 years. Or let's keep it simple. Let's say we will keep this data for 1 year.
1 year. Okay. So all right, got it. So in the last question, I think is let me see. Okay, the last question I think it will be so I was possibly thinking that doing some web crawling, though you will meet with some URL. I mean, like some content that possibly duplicate. So do we consider the content duplications, or like we can ignore the duplications?
Yeah, so I think the duplication, that will be one part of your design. So you during the process, you should have some like components, or have some service or some other parts that to help you deduplicate all the results in from your output. Yeah.
Okay. And yeah, and the last one is because this is web crawler, so I also think that so we also need to like refresh this in a period of time, because there will be new page, new content drawings. So so are we consider the page refresher?
Yeah, so that let's assume that we will have some cron jobs, that so that this crawling will be run at 12 a.m. of every night.
Okay, got it. So yeah, so I think that can be a feature requirement. Let me flag this one. So there will be a search engine. So sorry, it's a crawler for search engine, which is indexer, and it's a million page. It's a million QPS, 100 QPS now, or a billion page per month in the futures, and the HTML and photos and storage for 1 year, and duplication is need to be considered, and we also need to consider the refresher. Okay, so I think that can be a feature requirement. Do you think that we miss anything, or anything that we need to consider?
Not for my part. Let's move on to the next one.
Okay, all right. So for the non-features, okay. So I think so first of all, do you have like any requirements for the non-features, or we can brainstorm some non-feature requirements?
Yeah, I think what about you propose your points here, and then I can add some parts that if you miss anything.
Yeah, okay, sounds good. Okay, so I think that so I think I have like 3 things on top of my mind. The first one is scalability, because yeah, scalabilities. And then the second one is robustness. It's like not gonna break the so like if you crawl some dead page, it's not gonna break, and also the system is not gonna crash when this. And the last one I think is most important is the politeness, which I mean like because this is a robot, so it will send out a query, send out millions of queries possibly per second. So we need to control the threshold of don't be a dummy, right? So it's not like sending too many requests at one time. So we need to control the politeness.
I see. So yeah, so by one question, by robustness, you mean high available? You mean that any component or any service failure in your system that will not result in your crawler to be crashed? Does that mean?
Yes, right. That's the availability. Yes.
Okay, sounds good. And yeah, so I think I would like to add one last point that may not be important as the first 3, but I think we need to have some durability in here. That means that any URLs that we have crawled and saved in our system, we do not want to lose them.
That is right. Yeah. So that's correct. Okay. Yeah. Thanks for the reminding. Okay. Right. So does the none feature looks good to you?
Yeah. Let's move on to the high level design.
Okay. So, yeah. I was thinking that
okay.
high level is okay, and what about like we can do some estimation, like quick estimations, like take a few minutes. So estimate estimations. Okay, estimations. So I think we need to get two important metrics that we care about. Is the first one is the storage, and the second one is the QPS. Of course, the QPS you already gave to me. So I think this is the two important metrics that we need. So talk about the storage. I think this web crawling system is more like a read heavy. First of all, this is a write heavy system. So majority of the data is coming in instead of coming out. So and so talk about the storage, and we are let me see. So we targeting about 1 million page per month. 1 million page per month, which is so we need to calculate storage for 1 year, and then so we can extend to 2 years. So
sorry to break you. That let's do the calculation based on your target that we have 1 billion page per month.
Oh yeah,
In your second line, in the features that you said, I know.
Sorry, yeah, 1 billion page. Yes, 1 billion page per month, and so I was thinking that possibly text and photos for 1 page, averagely, it will take about 500 KB kilobytes. Do you think that makes sense?
Yeah, well, I think we can split so to
yeah, right, okay. Okay, I got it. So this one can be a text content. So then for text content, I'm possibly thinking for every average page, we can also estimate for about like a 200 KB per page. Do you think that works for us?
Yeah.
Or yeah, okay.
Yeah, that sounds good to me.
All right, so so this is for about a month, and so if we want to get a year, so we need to use this page to plus 12 months. So this can be a yearly storage. So I think we can leave the calculation there, and then if we have time, we can come back to make this.
That sounds good to me.
And then so for the photos, it's basically the same thing. And let me draw it here. So I was thinking possibly storage photos. We can use some object store to store it. And same thing happening here. I was thinking possibly for photos we can use 1 megabytes, which is 10,000 kilobytes as average size for the photos, and then storage for 12 months. Yeah, so if we want to storage for 2 years, so that will be 2 years here. Okay, right. So I think that's the storage. And for the QPS, so we can initially use the QPS that you provide, which is 100 pages. And if necessary, we can also extend to the QPS that we get in here, which is I think the calculation is the formula will be 1 page, 1 month page, 1 billion page multiply. So this is for a month, which is 1 month is 30 days, I think, and then multiply the 24 hours, multiply the 360 seconds. So this is the second, and we can get the QPS estimations.
Yeah. So that sounds cool. Let's move on to the next part. Yeah, I don't think we need to spend too much time here.
That's right. Yeah. Okay.
Yeah.
Got it. So
yeah,
thank you.
That's good enough.
All right. So so we can have because this is a I think because this is more like an internal system. So I think the API in this one can be quite easy. So so we can based on the feature requirements to do our to do our API design. So the first one, I think it can be so we can say so it can be a get. So more like a get indexer. So get index. Get index is for this can be called from the search engine system externally. So inside of this get index, so I think we can have how can I see? So possibly we can have probably some keywords. And also a time range, such as like start time and end time. And possibly, or maybe we can besides the keywords, we can also call this as a content ID if we want to extract an entire page or the photos, because we probably have some external system to handle this conversion. Like you put in some keywords and they do an elastic search to get some content ID, and then so I think the in the end, so only the content ID is the important thing. So yeah, so this is one index, one API. So I think probably the other API is for the input. So so we can have a so we can have a system that allow the customer to send in some seed URL to start the crawling. So so it can be like a put seed, which in here there can be a list of so it can be a list of seed list. So seed list. So so by putting this seed list, you can our system can start working to initially to start crawling the page. So I think this can be two important APIs.
Yeah, how do you handle the periodic scheduling? Let's say that in your feature number 6 that you have a refresher. I suppose you should have one more API function to help schedule the repeated crawling.
Yeah, that's right. So so initially I was thinking possibly there can be some configurations inside of doing this manually, but yes, we can also do this as an API, and then use the API settings to override the settings inside. So
because we may want to crawl like at the end of every day, but we can also use this API function to, let's say, crawl like twice a day, or like 4 times a day. So yeah, so I think add one more function should be more better.
Okay, yeah. So So I think this is my idea. It's we can set a start time, and for example, like yesterday, and the system can work as like from he can calculate from for example, I give yesterday like 12 hours exactly at midnight, and then so the range can be 86400 seconds, so which means entire 24 hours. So so the system is triggered by this period. So it start from the midnight yesterday, and every 24 hours the system will start to trigger again to do some page refreshers. So so if we want to reset the time from like once a day to twice a day, so we can change the second to a half, so it will trigger twice during the day. So yeah,
okay, yeah, that I think that will work. Yeah, this looks good to me. Let's move on to the next part.
Right, I think the last one is I mean, it's not the last one. So it's we can talk about the high levels. So as we talk about the API, so we here has a put seed modules, which is the seed URL. So we have a very small modules to handle this request. But I don't think this is very important, or this can be a little bit out of scope in here, is how we handle like tons of input, like tons of requests. So I can verbally describe what happened is we probably can use some elastic computing. So like a load balancer to and then so some API servers in the containers to handle this input. So if there's like, if we expose this API to outside as a service, so like tons of input coming in, so we can still handle this request without dropping any request. But I think probably this is a little bit out of scope in here. Right, but anyway, so based on these modules, we have the seed URL coming in. And after that, we can have a module that specifically handle this URL. We can talk about like this, maybe URL managers. So what they does is possibly this is a queue inside, or this is a queue inside. So it will manage the URL that's going to be crawled. So we can dive in details for this URL manager, because I think this is really important. But after this URL it's a queue or something, we can have a HTML downloader. So what the downloader does is it gets this URL and then so downloads the content and storage and download the content. So because this is a URL HTML downloaders, so it needs to rely on a DNS external DNS to resolve the the web page, like the URL. And the last one is after we have this HTML downloaders, we get the content, and we need to have some content parsers. This is completely to resolve the content. So what in my mind is what in top of my mind is it has like three things. So the first thing is it analyze all the text inside this page, not the detail of the text, but just to abstract the text out. And then it just, I mean, here this is completely HTML text, and then so we can save the text and compare and do some text compare, like maybe we can do some MD5 hash value compare to see if this is unique or not. And the second thing is to the photos. It's the same thing. So let me try here. So text text photos. This is all the text, photos parts. And the last one is the most important, is for dynamic page paths, because majority of the page they use Ajax or some JSON, JavaScript. So it's dynamic. So we need to handle some dynamic parsing inside. I think it's called server-side rendering something. So anyway, so after this, we can get the content out. And the next step is we need to consider about the one of the requirement in here is the duplications, and it's the duplications. So we need to have a modules that can compare deduper. So we can call it content dedupers. So what it does, what the concept in here is, I was thinking possibly is like that content storage. So content storage, and then so when the content coming in, it's not going to first storage in here, but it's going to the dedupers. And deduper is interacting with the DB to check with this content if it exists or not, and then so it will decide whether or not to continue storage this content. So for the content storage is more like a object store with kind of a key value pair storage. So the key is the MD5 content, and then so the content is actually the object. Right, so it's like the key is MD5, key is MD5, and the value is the content. So it's the so in this case we can quickly know that what is changed, what is not changed, what is new, what is not new, like using this way. So if we confirm that this is a new one, this is new content, so we need to do an extra step is because we already analyzed these content. So we can let me draw the text here. Let me draw the blocks here. So we can do two things. The first one is completely for the HTML text. So we can take the link out. So it's more like facing the link, facing the external link. So we can do a link extractors. So this one is completely mining on the text, and to get some to get a list of URL that the URL is inside the content. So this is the task number one, and task number two is for the photos. For the photos, I was actually thinking that possibly we can do something related to photos, like photo analyze something, but we can of course dive in here, but we can just leave the photo in here. So so what the next one is? Yeah, please, do you have questions?
Yeah. So so for this link extractor and the photos, what's the purpose of these 2 points? It's like, are they like separate service, or like they're just a storage? Yeah, I'm kind of a bit confused here.
Yeah, I think this is a good question. I think I was thinking the extractor is a service, but the photo I'm not quite. I think probably we can leave it here, like, or maybe we can delete it. So because for the photos, I don't think that we need to do something else. We just get the photos, and after dedupe, so we just store the photos without, doing some follow up. But for the text is we definitely need to follow up. Is based on the text we need to analyze, such as there is a harf href. So we get the harf is we know that this is the next hoop of this page. But so we get this, we can specifically intercept the URL in here. And besides, we can make this short URL to a complete, like a relevant address to the absolute address. So to create a complete URL. So this is more this is the task of the URL extractors. Okay, and the next one is the URL filters, I think. So because after we get this, so we can have a quick key value store to have some like a blacklist of this URL. So sorry. All right. So the URL is can double check in this blacklist if this is some dead URL, like some bad URL. So we can ignore. So this is mostly the thing that in my mind for doing some URL filters. So and the next one is it's the same thing to similar to the content is the URL dedupers. Like if we already crawled this URL before, we can just ignore that URL. So so it's possibly the same thing in here. And then so after we dedupe this URL, so we get some fresh, the new URL, we can send back to the queue, so send back to the URL managers, and it can be like this. And of course, the downloader can create some blacklist if they get some like 404 arrow, something like that. 404 and some 404 or something like that. So I think overall, this should be everything that from the high levels of this URL of this web crawlers. Do you think that we miss anything, or anything that's specifically that?
Yeah, I would like to discuss a little bit about this content deduper. So yeah, so my thinking is that the deduplication mostly rely on your DB that of the content here to do the dedupe. So so I think in my point of view that after parsing that we can just do this link extractor and we can move the DB here to the container parser. Yeah. So yeah. So that's just my point of view here. So would you mind a little bit more that why do you need this container deduper as a separate service?
Yeah, it's a good question. So I was thinking from the microservice point, because if we want to scale out the system, we possibly need to make each module as its unique task. So just from microservice point of view, so it's definitely indeed you can merge the dedupe process with the content parser, because after you get the content parser, you know that you can directly get the MD5 value, and after you get the MD5 value, so you can check with the DB, and if the MD5 value is not there, that means this is a new content. So you can you can store it. So you can go to store the content and then continue to the link extractor. If the content is already there, there is a conflict, so you can just stop everything. That's definitely doable. So just from the design perspective, so I make the deduper as a separate module because one more thing is possibly I was thinking that deduper can handle some can be implemented by some like memory cache some cache, so it can have some faster compare. Because if you embedded the compare code with the content parser, that's not good, because that's not that's not scalable, because in the future it possibly can have like that. So you can maybe have several workers as content parser. So after work, and then so they will all generate some content. So, and the content will goes to the content parser, and the content parser is implemented by on the back. There is some like a memory cache on the back, so it can acquire this tons of MD5 value and interact with the object store to make a faster reactions. So this is my purpose to decouple this content parser with the content dedupers.
Okay, I see. So okay, so then that makes sense. Okay.
Same thing to the URL deduper as well.
Okay. So
yeah, I was also thinking that I missed one more thing is I was thinking the indexer because I forgot to draw it because the indexer.
Yeah. I think that's not the key part of our
right.
Design topic. Yeah, I think let's forget about it. So
right. One more thing else. Yep.
Yeah. So you can go ahead, and then I can post some of my question here.
Okay. So one more thing on top of my mind was I can talk about the URL managers, because I think URL manager is the most important among the system. Yeah, of course you can ask me a question, or you interested, which part you're interested in.
Yeah. So okay, so I'm thinking about that. What about so what about the container parser when it's doing some parsing jobs and the service just crashed, the machine just get down for some reason, maybe from and the URLs parsing to this service just get lost. So how do you solve this issue?
Oh yeah, okay, this is a really good question. So let me think. So yeah, so I think, let me see. So first of all, from the queue, so we pulled a URL and then get URL content. And then so this crashed. Yeah, so let me see. Okay. So yeah, this is indeed a good question. I was thinking that so one thing is because the URL is not like because the content parser is crashed, so the URL for that page never goes into the DB. So it is have chance to to be crawled again. So this is but this is not but this is not like but of course we're gonna lose this page. The other thing is the second thing is I was thinking possibly can have some retry mechanisms, like if the content is crashed, then so
no, you cannot retry, right? Because the URL was saved in the memory. of that machine. So once the machine gets done, that all the content saved in the memory was erased totally. So that when the machine gets up, yeah, because your container parser is stateless, right?
It's stateless,
so that it didn't track all the status of all your URLs, so that when it gets done, or when it gets crashed or get down for some reason, that it definitely doesn't know that what happened to that URL. So yeah, yeah. What about, I think your whole design works, but I think we lost tracking the status of each URL. Let's say that a URL may have a life cycle, like let's say that yeah. So for a URL's a life cycle that
right. Yeah, that's good. Yeah, that's good.
Yeah, it may be let's say, firstly, it will add it into our system. So let's say it will be submitted, and it can be after downloaded. It may be changed the status of downloaded, and then parsed, and then saved or removed due to some duplication, and then yeah. So I think that's basically a brief life cycle of the URL. So but in your system, I think we doesn't keep track of it. So that's I think that's a part that we can improve. So
yeah, that's good. Yeah.
I
think possibly we can have some key value path store, especially for tracking this URL cycle. Yeah, in a period of time. So for like when the URL, when we get the URL, so we can hash the URL into a hash value, and then store in the DB with the status. So every time, every module, it will goes to this DB to update this like I mean the key value store, like update the status. Yeah, right. So
okay. Then let's skip that part. Let's dive in deep into the URL manager. Like I just said before, let's dive deep into what's the detailed responsibility to take, and yeah, you may have a more detailed design of this URL manager.
Yeah, right. So because I was thinking that URL manager can have several responsibilities. Match to the non-feature design is especially is the politeness, because URL manager is let me draw in on the bottom. So so initially let me see. So this is a queue. I think okay. So so yeah, initially, so we can have a queue where so when the request coming in, so so it's a very simple queue, right? So all the request is queued inside the inside this one. But however, the URL manager can have two more tasks. So one task is you need to handle some politeness, which is control the speed. So let me think a bit. Okay. All right. So to think to consider about the speed, so we can have queue selectors. So this one is more like a process that listen to this queue. So every time, so it can control like it's more like a rate limiters. So so for example, if I want to control the rate, it's actually a separate topic, the rate limiter. If you're interested, we can discuss like token control, like rate limiters. But in here, so we can actually control that how many requests we can pull from this queue to control the speed. But one more thing is to increase the scalabilities. We can actually, with the help of the queue selectors, we can actually have several queues. So it's more like a distributed queue. So so each queue it can handle each queue can handle different requests. For example, based on alphabet orders or based on some pre-configured order. I would say pre-configured is more accurate. Such as order like A and B. So this is suddenly comes to my mind is so I think pre-config is more better like that. So if we have this, if I have this way, so we need to have queue load balancers, and this queue load balancer will actually search for a preset. This is a preset map tables. This is a preset map tables where like you can possibly have some for maybe some like that. So let me first finish this first. Okay, so like this. So and it will goes to check with this one. So what this table does is so it can based on so it has several things. I think firstly it can have some based on some preset alphabet orders, some like if you crowd apple.com or if you crowd like TikTok.com. So so it all goes to specifically one queue. So you can based on different content, you can differentiate the queue. This is the first one. But it's still possibly it might create some hotkey problems. Like one specific queue is overloaded while the other queue is lightweight. So we can also thinking about based on the queue status, like we can offload some request to the lightweight queue. So yeah, or because of the because we have the map table, I mean, like we also can provide some priority things. For example, if among all the web crawling, you want to specifically know some important web page, such as you want to crawl Facebook, and then you want to crawl TikTok. So to get some content, so you can set in the map and use a unique queue to handle this task. So in this case, those unique requirement inside the queue will not be blocked or will not have drawback.
Okay, yeah. I think I think our time is up. So okay. I think I briefly get your point here. So let's finish our system design interview here, and we can have some feedback discussion.
Okay.
好，
yeah.
好，那我们来复盘一下吧。
OK， 复盘一下。
对，然后我从头来说一下，然后基本上从就是design 的，我来说一下，就是我觉得completeness 没什么问题，就是有一个 已经有一个 complete solution here。所以我觉得 completeness is good。对，然后这个我们从下面说，然后 feature 没啥问题，然后 non feature 也没啥问题，这个 estimation 这个对，一个小的知识点，我不知道你知不知道有一个 string format 叫 cron。就是对，是一个Linux 里面就专门用来 schedule 这个就专门用来 schedule 这种 repeated job 的这种 format，就你可以 specify， 比如说就是从今天开始每一个礼拜五的晚上10点钟，然后我来 run 这个，然后每一个对，它有一个约定俗成的这个 string format， 对。
那我查一下，哎，这个应该是一个 setting 还是一个 API 或者是个什么东西？我听上去这个和那个 Windows 那个 Task Scheduler 很像，就是它是一个 setting， 然后你什么时间，然后 kick off 什么 program。
对，然后对，你可以回头你可以看这个，我先发给你啊，我先发到我先直接贴到这里吧。
OK，
对。
OK。
对，然后我们来说一下 design 吧。我觉得 design 是有点问题的，就从我个人的 point 来说，就是对，就是然后第一个很严重的问题就是我说的这个，就是说你没有 track 到这个整个 URL 的 life cycle， 那我就不知道，就是说如果其中某一个 component failure 了，那你怎么来就是recovery from previous job？
没错。
就是对，就是比如说你的 URL 刚刚提交到了这个 Q， 刚刚提交到了这个 URL manager， 然后这个 URL manager 挂了。然后那你下面就没有，然后再往下每一步都有可能挂，那你就没有 track。我觉得应该会有一个 centralized 的，就是一个简单的方法是有一个 centralized DB， 然后来 keep track 所有URL 的 status， 然后这个 DB 应该是 relational 的，对，然后
OK。
然后来确保这个它是 atomic， 因为同时会有 multiple components 来这个对，然后我来说一下这个 design。design 有一点问题。我大概会给一个 OK 啊，这里对，因为 fault tolerant 其实是 URL crawler 的一个重点。
I see。 OK。对，我可能想的就是 fault tolerance 就是那个程序不会挂，但是这其实是一个 implement 的问题，它不是一个 design 的问题。
对，它不仅是那个，它不仅是
对
yeah， 然后simple ways to use the centralized DB to keep track of status。那个就除了这种 centralized 的方法，还有一种是 decentralized， 就是你每一个parser 都把你就是把你收到的所有的 URL 都存到自己 local 的 disk 里面。
对，
然后
如果成的话，然后它就出来的话就删掉，然后不出来就继续在。
然后对，这里其实都没啥问题。然后对，如果我觉得你如果是这里有个 Q 的话，就有一个分布式 Q，就有个分布式 Q 的话，我觉得你最好就是把它放到外面来画。比如说如果是我的话，我可能会就是把它
对，
放到这里。
其实我也觉得这个有点别扭，然后对，
就是大概是应该是它要放到这个，然后它要飞过来，然后它要大概是这样，对吧？然后
对对对。
然后这个队列也有可能挂，那你怎么确保它不挂？就是你就简单一点，就是用卡夫卡或者这种现成的 business solution， 然后确保它是 durable 的。然后对，然后对然后还没有时间讨论到 scalable， 然后对对，我觉得整体 design 没啥问题，就是思路就是这个 data flow 都还挺好的，就是fault tolerance 没有考虑到，然后scale 没来及时间讲，然后其他
DB 我觉得好像也就是应该在，
我觉得 DB
你
对，我觉得 DB 你其实没怎么讲到，就你大部分都是 key value storage， 是吧？对，然后对，其实 DB 也是蛮重要，然后没啥。对，如果我一定要给个 rating 的话，我可能6.5吧。对，
我觉得这种要 senior 肯定是，就我现在 confused 的地方就是，我觉得这东西就是 senior 肯定是过不了的，因为我的 confuse 在于就是我不知道怎么能在45分钟的时间内就把这东西说到就是 DB 什么什么的。我觉得可能我看了一些别人的那个 design，我感觉可能他们就是在前面省了特别多的时间，然后特别快就进入到这个 DB 的环节，然后就是说，然后 DB 什么根据你的 QPS，然后判断 DB 用什么，然后包括 DB 自己有什么什么特性什么之类的，然后 DB schema 啪啪啪就写出来了，然后 high level 也能说出来，就是等于是他把 high level 说出来，DB 也说的特别清楚，然后基本上就稍微再 dive in 一个点就结束了，但是这个过程会给人觉得特别 senior 的感觉。
对，就其实对，就是其实 senior 主要还是就是我当面试官给你讨论一个细节的点的时候，就是钻进去的时候，他
都能搞定。
面试者都能搞定，就是应该就可以了。对，其实我就因为我们没涉及到这块，所以就都没有讲partition 然后 sharding 的问题。对，是其实还有很多就我不知道你有没有看过那个，就是那个 YouTube， 我不知道你是看啥资料准备的这个。
我是看的那个，就是有一本书叫什么 Alex 那个 Design the System Interview 那本书。
对，我觉得我给你推荐一下这个吧。我觉得这个YouTube 的这个人讲的，对不起，没复制到。又没复制到。你想，对不起 ，copy paste。对，我觉得这个就是那个 Scott 十他讲的，他就讲这个讲的挺好。你回头可以有空可以看一下，就是对，not covered，fault tolerance。
对，我觉得我是没错，我最近是听那个就那个俄国大哥那个，我靠，我觉得他讲的挺好的，但是他讲的我觉得对。
你说那个 system design 那个 channel 是吗？
对。
东欧的那个他确实讲的挺好，我觉得他 基本上每一分钟都没有浪费吧。
对，我靠，我都看他那，我看完都头疼，我觉得信息量太大了。
对，因为我看他，我感觉我最开始其实他口音挺重的，我没能太听懂，然后我后来就我还要边看字幕再边听他的那个。
没错，我现在也是看字幕，然后听他那个。啊
对对对对，
，OK，
然后我把这个放到这个里面嘛，然后回头你可以。
哎，谢谢，这个还是挺好的。嗯，那后面你还有空参加吗？我觉得你是不是后面就可以放飞自我了？
我应该会，就如果不出去的话，我应该还是会参加的，因为我觉得design 是一个一直要提高的这个东西，因为然后反正就每周就当跟别人聊聊天嘛，也挺好的，我觉得。
对对对，我觉得也是，就是咱们可以就是平时能多交流。我现在就感觉就是，嗯，其实我在美国的这个工作，就2年多，这工作是第一个工作。我之前是在中国工作，然后我之前是通过读书的方式来的，所以中间还 gap 了一段时间。所以其实我真正就是，所以我特别虚嘛。我真正的这个工作时间也就2年多，咱们把中国那个跑掉的话，然后
但肯定还是要算嘛你继续说。
对，就是我的感觉就是 look back 这过去这三年时间，我觉得真的应该，就平时没事儿就要看看 design 的东西，然后平时就要看看那个口写，就是刷题，因为就是保持这个状态吧。因为我发现就是我觉得 LinkedIn 还是比较 professional 的，就是做的事情，然后微软其实大部分的组都比较的松散，就都很闲。然后大家就是瞎忙，就忙不到点儿上去，所以平时其实很多事情，但是真的不如就是多给点时间给自己，然后准备一些这些东西，我觉得更好一些。这样的话，
是。
对我现在就想，我这次之所以就是比较谨慎，就也确实准备1年的时间，就是想，嗯，我看我身边有一些人，他们的操作都是。我感觉他们每半年就会去出去面个试，就他说也不一定就真的去，他说反正就是面一下，万一呢，对吧？万一行了呢，然后就让自己保持这个状态，然后就那些人的就各种骚操作，他没有抽到 H1B，然后他就开始面试，嗯，他他面中那个公司接了 offer 以后，然后他现有公司给他抽 H1B，然后他的那个新的公司给他抽 H1B，
对，
然后
是可以的。
对对对，如果他新的公司抽到了，他就跳过去；如果他老公司抽到了，他就撕 offer。我觉得我操，还可以这样，就是一直在面试，感觉。
对，当然可以，就是还是怎么说呢？这种还是很那个的吧，就是骚操作的，就那个怎么说呢？一亩三分地里，就是不是人均都是五年一 experience，Facebook 16嘛。
对对对，我就觉
这
得
就随便发个包裹，就有人说，哎，怎么这么低？这么低还好意思发出来？
我都不敢看那个，就是我都不敢看那个包裹了，他们那些人实在太牛。
哎，怎么说呢？就还是跟人不一样嘛，就是怎么说呢？就是有团体，如果在加州或者在西雅图，如果你有个一直刷题、一直面试的团体的话，还是会好很多。比如说在加州，他们清华的，然后上交的、中科的都是一起的，所以很多操作都是前人告诉他们的。
真的是啊，就是，哎，这个太重要了。反正我就觉得后面其实就可以差不多每2年就一跳。我觉得像你如果，其实我也一样，就是我觉得我大概率就是 SE2，就是我觉得不太可能 Senior，但是尝试一下吧。然后我觉得就是拿个 SE2，然后2年再跳 Senior，我觉得这一点问题都没有。所以我觉得就保持这个状态吧，慢慢来，反正。
对，我觉得状态肯定就包括我也跳槽成功了，我肯定我都觉得我不能松懈，因为我的 feedback 是 design 不好。
因为我发现大多数人就是现在，看到就是都是折在这个，就是在 design 准备的不够好。但是说实话，我现在随着我的准备，我越来越感觉，我也跟一些 senior 人交流过，就比较少，但我就感觉就是你不管你再怎么准备，就是如果你能说你是一个，就像我这水平吧，就是2年工作经验，如果说能准备一个让人心服口服的 senior 的，除非他降低这个 bar，如果他准没心服口服的 senior 的这个东西，我觉得基本不可能，我感觉。所以所以我现在越来越体会就是，你比如你进那个组，如果你这个组本身就做这个 distribution system 的，所以其实你会很容易理解一些比较深刻的东西。所以当你就具备了这某一方面的自信，然后等你在面试的时候，你就可以把它归到你这会的这一类里，然后你就能说服你出来，所以很容易就体现出这个 senior 的这个自信了。我觉得像我现在做 data engineer，我真的是没有办法体现，所有东西对我来说都是新东西，除非除非
是这样。
做那个 Spark 那些，但 Spark 我觉得2年我对 Spark 的掌握也不好。
嗯，哎，咋说呢？就我觉得，如果你工作是做这个，肯定就对这个了解就会比平常人要深一点。不然的话，其实如果你工作，对，这其实也是我选择 LinkedIn 就去做infra 的一个原因。就我觉得
嗯，
你如果做 infra 的话，就比你做 backend 可能要好一点，就是因为 backend 你都是 call 这些不同的 service，你反正当掉了也不是你的责任，你也不用管。
对对对对，就是我第一个工作是做 network，然后其实就是也是 infrastructure，然后但是我理解是这样，就是如果你分成那个网络基层协议的话，就
嗯嗯
是可能比较重点考虑 network infrastructure，可能重点考虑这个distributed 是在四层左右，就是HTTP 和 TCP 的这一层，就是三
嗯
层四层，就
嗯
是它会特别多的考虑这个distributed 的这个性能的问题。然后如果你做 backend 呢，你就是7层，你在第7层你就看不到下面。然后如果我当时做 network 是2、3层，我看不到上面。然
哦
后
，I
所以
see。
就是我这边也有这个，就是就是那个叫 fault tolerance，还有这个
哦
performance 的问题。但是呃，我最高级的这个 knowledge 就停止在那个那个叫RDMA 这些东西，就是快速读
，OK，
取。
我知道。
然后，但是它是具体，它用 RDMA，包括那个它发那个 RPC，它过来以后，它是怎么能够做到就是 load balance，其实 load balance 我也 cover，但是它是怎么能够就是这些呃什么 replica 这些我就不知道了，就就
嗯嗯，就
就就
这对，其实很多 design 在不同的领域都有相似的地方。对对对。
对，所以我就特别想能进一个就是互联网公司做印发，比如像 Facebook 或者像这个 LinkedIn。我觉得像 Google 其实都不一定，就是它就 Google 也就是它分太细了，所以它也不太那个，就是互联网公司它会把这个印发集中在就是他们管那个就是说你去起一个 container，一直到就是维护这个 container service，然后一直
嗯
到这个建立这个就是你在 Cloud 这个平台上去写这个服务模型，就是他们管这个叫 infrastructure。但 Google 的话呢，可能就是说这个也算 infrastructure，但是他们会把底层的，比如像那个hardware switch，就这些也叫 infrastructure。
啊，那这个太底层了。
对，所以你进去就写 C 什么的这些，我靠，
这个就没
就
什么意思了。
不太好，就
对对对
没什么意思。
对对对对。
所以我现在觉得有意思，也就是这个3、4层，然后或者就是写backend 搞 business logic 就。
对对，其实我觉得就两个方向嘛，就找工作的话，我也是，我就主要还是就是 prefer 这个 infra 或者 backend，因为我写过，我之前上学的时候写过一点那个 front end，我觉得 front end 哦 我不喜欢，然后 OK
OK，那今天咱们这么着
OK
辛苦了。
Anyway，那今天就这么着，对，
那今天这么着，辛苦了。OK，
好，
那
谢谢
下周的话就还是你呗。
对，下周就
你要是
换我来吧。
有空的话，对。
对。
OK，你还可以发个 topic 给我，这样咱们都可以准备一下。
好，没问题。
OK，拜拜。
好，拜拜。
拜拜。